Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video, we're going to do another one of those Codewars challenge sessions. So we're going to go to codewars.com and I'm going to solve some katas. That is what they're called. And you can watch my thought process if you're interested in that. The first video got some quite positive feedback. And of course, you can also, meanwhile, try to solve the same challenges on your own. Today, we're going to start with 7Q. We're not going to do the 8Q challenges because they were too easy. 7 is still quite easy, but we're going to start with 7 here first. And again, this video is going to be kind of uncut, unscripted. I didn't prepare anything, solving problems on the fly. Of course, if my thought process is too confusing and goes on for too long, which is definitely possible with 6 and 5Q challenges, then of course I'm probably going to make some cuts. But the goal is to make it as uncut and spontaneous as possible. So let's go to 7Q and sort by popularity. Let's see which one of those we haven't solved yet, or I haven't solved yet. Let's pick shortest word. This seems to be very trivial. What do we have? Simple, given a string of words, return the length of the shortest word or words. String will never be empty and you do not need to account for different data types. Okay, so this should be quite simple. Again, we need to put this the upper right corner. There you go. And now, oh, I clicked on next kata. I already did that. Okay, train again. No, we don't want to do that. Sorry. What do we have? Descending order. Let's see if we can do this one. Your task is to make a function that can take any non-negative integer as an argument and return it with its digits in descending order. Okay, essentially rearrange the digits to create the highest possible number. Okay, that's interesting. It doesn't seem too trivial. I mean, we can do it definitely with a string function. So here right away, we're going to zoom into the code. There you go. So the goal is we have a number, an integer, not a string. And this could be something like that, for example. And our goal would be to return the same number, or not the same number, the same digits in descending order. So in this case, 97731 to create the largest possible number. So I think this shouldn't be too complex. Now let's do a very simple thing. We can say num_str equals string of number. So we can definitely do this with a string function. And then what we can do is, of course, we can say, okay, digits equals, and then we can say int x for x in num_str. And then we can say digits.sort return we now have those. Let's see if this works like that. Join digits. I'm not sure if this is going to work. Let's see. Let's just test. No, okay, it doesn't work because we have integers and we're trying to join sequence item 0 expected string instance. Okay. So we need to sort. Actually, we should be able. Let me just think about this. Can we not sort a string? Not sure if we can, to be honest, but let's see if this works. No, this doesn't seem to work. Yeah, string doesn't have that. Okay, but what we can do is we can actually do it like that. And then this should work. I mean, no, in the end, we need to return an integer, right? So let's see first of all if this works. Yeah, there you go. So, and of course, we need to sort in descending order. This is also important. So let's see Python sort descending, how this is done. I guess with a keyword. Yeah, there you go. Reverse equals true. So we're going to say digits dot sort reverse equals true. And in the end, we're going to return this string as an integer. Now, I'm not saying that this is the most efficient way, but this should work. Test. There you go. Now, we're going to do an attempt, or do we want to do an attempt already? Now, first of all, let's think if we can do this in a way smoother way. I don't think that we can sort immediately here. I mean, we can try the keyword sorted, or the function sorted. Sorted Python reverse. Does this work as well? Yeah. I mean, we can try to make it a one-liner. We can try to do sorted this here reverse equals true. And maybe we can get rid of that line here by doing that. Yeah, this seems to work. And now we can just replace num_str with str of num. And we can get rid of that. And now we can go ahead and say join that and get the integer of all this. And now no one can read what is happening, but this should still be the same code if I didn't mess up anything. There you go. Let's see if it works. Yeah, works. I think that's a pretty good solution, to be honest. Let's see what the other people are doing. Take some time. It's always loading for so long. What is it actually loading? There you go. So this guy has int sorted string. Okay, we can do sorted on a string. We cannot sort a string, but we can do sorted on a string. Okay, I didn't know that. So this is essentially the same solution, but without the list comprehension because we can sort a string immediately. But that seems to be pretty much the best solution. So we can say that this is a good solution. There you go. Okay, so let's go to the next one. And we're going to pick a 6Q challenge, which is going to be slightly more challenging. Sort by popularity. And we're going to pick find a parity outlier, bit counting, take a 10-minute walk, create phone number. Let's do bit counting. Well, let's see what it is. Write a function that takes an integer's input and returns the number of bits that are equal to 1 in the binary representation of that number. You can guarantee that input is non-negative. The binary representation, okay. So, I mean, with Googling, this should be quite easy. We just have to see how we can transform it into binary. I think there's a function in Python for that. Python decimal to binary. Convert decimal to binary in Python. Wow. Wow. Does this really work? What do we have here? We have, okay, that is sick, to be honest, if that works. So let's just do it like that. Or actually, let's do it in the idle first so that we actually see if it works or not before we do something here. So 3.9 is what we're looking at or looking for. So what did he say? He said this format here, dot format, and the integer. So basically, I would have to say 0 colon hashtag b and then dot format and a number 1, 2, 3, for example. Okay, so it starts with 0b and then the binary digit, the binary number, or the binary representation of the number. That looks kind of cool. So, can we do that with an f string as well? I'm just interested, just curious. How would we do that? 1, 2, 3, hashtag b maybe, not sure. Yeah, works as well. So we can do that with an f string as well, which is what we're going to do. So if we take that and we just say from that, does this work like that? Okay, this works. And now all we need to do is we need to count the ones. So this here dot count 1 should be the solution. So basically, we have return f string of n colon, what was it, b hashtag or hashtag b? Hashtag b. And now we ignore the first 2 characters, dot count 1. So that should actually work. Let's see, test. Okay, this works, but I think there might be even a better solution. Maybe something, I'm not sure actually if it works easier than that. Maybe with some bitwise operations that I don't know how I would use them right now. But I think that's actually a pretty smooth solution, to be honest. Or actually, I'm going to flex even more. I'm going to say count bits equals lambda n. There you go. Does this work as well? Wow, it works. Okay, let's see if anyone has such a great solution as well. It's again loading for too long. But this is actually not really complicated. I wouldn't say this is a 6Q challenge, to be honest, because it was quite easy. I think it was almost as easy as the 7Q challenge. And last time, I think the 6Q challenges were a bit more difficult. So we have a function bin. Do we have a Python function bin? Okay, this also works. Okay, didn't know that. But besides that, the solutions are all the same. Okay, here we have a bunch of people that did the same thing that I did, but with bin. So actually, yeah, looks like we have a pretty good solution again. All right, let's do another 6, and then we're going to do a 5Q challenge, if the 6Q challenge is not too difficult. So we're going to filter by difficulty. We're going to go to popularity again. Let me just zoom out a bit. What do we have here? Decode the Morse code. No, I'm not interested in that. Create a phone number. The Fibonacci sequence. Sounds interesting. Let's click on it. What do we have here? As the name may already reveal, it works basically like Fibonacci, summing the last 3 instead of 2, okay? And worst part of it, regrettably, I won't get to hear non-native Italian speak. Okay. So if we are to start a Fibonacci sequence 111, we have this sequence, but if we start with 001 as a signature, basically shifts the common Fibonacci sequence by 1 place. You may be tempted to think that we would get the same sequence shifted by 2 places, but that's not the case. Okay, we got a different thing. Well, to be honest, I'm not interested in that right now. I think it's not too complicated, but I don't want to do some mathematical challenges here. Let's see if we have something that is more Pythonic. Are they the same? What is that? Given two arrays A and B, write a function comp AB or comp same AB that checks whether the two arrays have the same elements with the same multiplicities. Same means that the elements in B are the elements in A squared, regardless of the order. What does that mean? Okay, 121 is the square of 11. This is the square of that. Okay, so basically A has some numbers and B has to have all the squares. Is that it? I think that's the challenge. Let's see if we can solve it. I think it's not too difficult, but I'm not sure that I understand what they want. So basically, all we would have to do here, if I understood the task, is we would have to say, okay, temp array equals x squared for x in array 1. And then I would say return sorted temp array equals sorted array 2. Isn't that the solution? Okay, that's the solution. That's not too difficult, to be honest. So just let me explain what I did here. I basically said, okay, we're going to create our own list with squares, and then we're just going to compare it with array 2. If it doesn't have the same values, then it's not going to be a correct solution. Now, the problem is, of course, that this may be not the most efficient solution. So let's see if we can find something that is better. Let's say we're going to create something called bit array. We're going to say, let me just think about this. It doesn't make a lot of sense. So if we don't want to calculate all the squares, can we do it? No, actually we have to do it, right? We have to do the squares because otherwise we don't know what the squares are. So we would have to calculate all the squares anyway. So why not do it? To be honest, I think that's a pretty good solution. So we're going to go with that. Let's see again. Test. Yes, let's do an attempt. Okay, no, we have one problem. What do we have here? Unexpected exception raised. Maybe if they're empty. If array 1 equals none or array 2 equals none, return false. Okay, now it works. Let's see what the other people have as a solution. But yeah, I don't see a way to do this comparison without squaring x, because in order to understand, in order to check if the squares are in array 2, you need to know what the squares are. So you need to calculate them for all the elements of array 1. Yeah, so basically this guy is doing the same thing, but with try except, which I think is not a clean solution because you should not use exception handling unless you have to, and you can do it with an if, so I don't know. Return none, not in. Oh, that's nice. Okay, yeah, basically we have pretty much the most common solution with the sorted. Let us now try a 5Q challenge, which is going to be significantly harder because I don't know why, but 6Q is very easy and 5Q is pretty challenging most of the time. So it's not something that you cannot solve, but it's quite difficult to solve. And it takes quite a lot of time. So let's see, we're going to sort by popularity. I have actually failed a 5Q challenge already. So hopefully we're not going to fail one here again. Let's see what we have. Let's go to what sounds interesting. Sum of pairs. Weight for weight. Let's see what weight for weight does. My friend John and I, each month a list members is published, and each month he's the last on the list, which means he's the heaviest. I'm the one who establishes the list, and so I told him, don't worry anymore, I will modify the order of the list. I was decided to attribute a weight to numbers. The weight of a number will be from now on the sum of its digits. So for example, 99 will have weight 18, 100 will have weight 1, so in the list 100 will come before 99, okay. So given a string with the weights of FFC members in normal order, can you give a string ordered by weights of these numbers? That should actually not be too difficult. Maybe I'm underestimating it, but it doesn't seem too complex. So, okay, what? We have a string or we have a list? I'm not sure now. Okay, we have a string. So first of all, we need to split. That's for sure. So we're going to see weights equals string dot split on space. And we can turn them into, actually we don't want to turn them into numbers. So we now have all the weights, and we can say full weight in weights. We are going to say order weights equals empty list. Or actually, what we can do is we can do a dictionary. We can say order weights is an empty dictionary. And then we can say for weight in weights, we're going to say sum equals 0. And then for digit in weight, sum plus equals int of that digit. And once we're done with that, we're going to say order weights of that particular weight is going to be the sum. So we now have this dictionary. And then what is the goal? We want to have the same list, but in a different order, right? Okay. So we would now have to say, let me just see, sort by criteria Python according to certain criterion. I think it's key, wasn't it key? Yeah, key lambda x. So I think it should be enough to say weights dot sort, and the key is lambda of a given weight, so x. And what we want to have is order weights of that x. Does that make sense? Not sure. We're going to return onto a string join the weights. Let's see. No, weights is not defined. Oh. This here should equal, oh, okay, yeah. What do we have here? 2000. Okay, the problem is, of course, if they have the same sum, we should sort them by length. So maybe we should first sort them by length. So weights dot sort key equals length. Does that make sense? That should equal. Okay, why is that now? I thought. Do we have instructions for that? When two numbers have the same weight, let us class them as if they were strings. Alphabetical ordering and not numbers. 9. It comes before the string. Okay. So maybe we should just sort in general. Does that make sense? Yes, that makes sense. Okay, so let's first of all see if it works on all. Yes, it works. Okay, fine. So order weight, what we're doing is we're just splitting the string so that we have individual strings of the individual weights. Then we're having a dictionary that is mapping a weight to the sum of its individual digits. We do that for all the weights. Then we sort them in alphabetical order, and then we sort them by using this dictionary. Now, I'm sure that we're going to see smoother solutions, but I'm going to just submit this so that we can do one last challenge. And let's see what the other people are coming up with. But I don't think that this solution is ugly. I just think it's probably not the best one. As you can see here, we have a one-liner. Join, sorted, string, split. Okay, key lambda sum int c for c and x. Okay, I think the principle is, okay, he's not using a dictionary, obviously, but the principle is not too different, but it is way smoother to do it like that. This guy has a helper function. This guy has also a helper function. Basically, instead of defining a dictionary, he's defining a function. Yeah. So we have a pretty long solution, but I don't think it's necessarily a bad solution. So let's do a last 5Q challenge, and we're going to sort by most completed. And where are my anagrams at? Do we have this one? Train. What is an anagram? Well, two words are anagrams of each other if they both contain the same letters. For example, blah, blah, blah. Write a function that will find all the anagrams of a word from a list. You will be given two inputs, a word and an array with words. You should return an array of all the anagrams or an empty array if there are none. Okay, that should be quite simple. So basically we have a list of words, and all we need to do is we need to say for w in words. And isn't it actually just, if I have anagram list is an empty list, and now for each word, if sorted word equals sorted words, oh, not words, w, then return, no, not return, anagram list dot append word, otherwise, no otherwise. That's it actually, right? Then just return anagram list. Does that make sense? Anagram list. Okay, anagram list. Okay, that works. But I think maybe let's just do an attempt first. Okay, it passes all the tests. This was quite easy. But I think we can do it in a better way. Let's think about this. Can we do return list comprehension word in words? No, word or w for w in words. But we are going to say w if sorted word equals sorted w. Shouldn't that be actually all we need to do? Oh boy, come on. Stop zooming. No. Why not? Oh, else. Else nothing, actually. Can we do it with that? For w in words. W if sorted, but we need an else. What do we do if not? Can we do that or not? W if sorted equals sorted. And what if not? Can we do it like that? Not sure. Python list comprehension if. But can I do it without an else? Okay, we can do the condition in the end. Okay. So, yeah, that makes sense. If sorted, let me just zoom into the code again. If sorted w equals sorted word. There you go. This works. Let's submit it. I think there are not going to be any better solutions. At least I cannot think of one, because that's a one-liner, a pretty efficient one. Maybe they're going to use different functions. What do we have here? Return item for item in words. Yeah, that's the same thing. This guy uses collections. This guy has a filter and a lambda expression. Filter lambda x sorted word equals sorted x words. I mean, that's also beautiful. But most of them use list comprehensions. That's fine. Alright, so that's it for today's video. Hope you enjoyed and I hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video and bye.